Welcome back to Grade 7 Math. This is lesson number 7.1, Understand Exponents. Today is the first of a two-part lesson/video involving exponents. In today's video, we are going to look at square numbers and cubic numbers. A square number is the product when we multiply a number by itself. The diagram below shows the first 30 perfect square numbers. Okay, and first off, I'm not going to expect you to memorize all of these perfect squares. What you're probably going to find by the end of our unit, though, is that you'll be able to remember between the first 10 and 12 perfect squares. And I know when you first look at these, you think, oh, this is 1 times 2. That's not the case. 1 is our base number, 2 is our exponent, and what this means is 1 times 1, which equals 1. Okay, 2 to the power of 2 means 2 times 2, which equals 4. 3 to the power of 2 means 3 times 3, which equals 9. 4 to the power of 2 means 4 times 4, which equals 16, and so on. You might want to put this video on pause. Again, not to study all 30 perfect squares, but I'd say at least the first 12 we should really work on memorizing. It'll help us with our work later on. So where does the idea of perfect squares come from? Well, the idea comes from calculating the area of a square. If we multiply the length by itself, we get the area of a square. So just look at this. We've got a 5 by 5 square. So what we can do is we can say, well, 5 times 5 equals 25. So we can rewrite that as 5 to the power of 2, or 5 squared, which equals 25. A cubic number is the product we get when we multiply a number by itself twice. So for example, 3 times 3 times 3 equals 27. Okay, and here's a shorter list. This is the first 12 perfect cubic numbers, and I find most people are able to memorize the first 5 perfect cubic numbers. After that, becomes a little bit more tricky. But again, keeping in mind this 3 means you're multiplying the number by itself twice. So 1 to the power of 3 means 1 times 1 times 1, which equals 1. 2 to the power of 3 means 2 times 2 times 2, which equals 8, and so on. Okay, and the idea of a cubic number comes from calculating the volume of a cube, like this Rubik's Cube that you see in the diagram. To get the volume, we have to multiply the length by itself twice. Okay, so looking at this example here, we've got 4 by 4 by 4. So 4 times 4 times 4 equals 64, but we can rewrite that as 4 to the power of 3 equals 64. All right, I'm going to give you a couple of examples on this slide here. So you're going to need to pause this video in order to solve these. What you're going to do is you're going to calculate the area of each large square. Okay, so pause the video so that you can write down your answers, and we'll take this up in tomorrow's class. Okay, now let's try it with cubic numbers. Again, we're going to write the area in exponential form. Okay, and we'll also write the area as a final number. Okay, and remember you're working with volume here, so you've got 3 dimensions to work with. If it helps, go back and watch the previous slide. where I gave you the example of how to work with cubic numbers. But right now, put the video on pause so you can complete these two problems. Okay, so now we need to try taking off the training wheels, so to speak. Okay, because you're going to get problems where you have to rewrite certain mathematical phrases in exponential form. So I'm going to do the first one for you. So we've got 14 times 14. If I want to write that in exponential form, I would say, okay, well, we're multiplying 14. We're multiplying it by itself. So that means 14 to the power of 2. So I want you to put the video on pause so that you can answer these two problems at home. Okay, now here we're going to do the reverse. We're going to write each of these examples as repeated multiplication, and we're not going to calculate the final answer. So again, I'll do the first one for you. Okay, the base is 11, and I see it's cubed, or to the power of 3. So that means I need to write a grand total of 3 11s, just like that. Okay, so put the video on pause so that you can do these two problems at home. All right, so at the start of tomorrow's class, we're going to take up the sample problems I've left for you here, and then I'm going to give you a selection of questions from your textbook. But until tomorrow's class, this concludes today's video.